A train is traveling at a speed of 90 km per hour. It's important to know that it's in kilometer per hour. Brakes are applied so as to produce an uniform acceleration of minus meter per second. Find how far. So basically the distance is to be found. The train will go before it's brought to rest. So what is that we are looking at? A train traveling with a particular velocity gets deaccelerated and comes to a rest. So how do we go across doing this? First is your diagram with a train on a track. So that doesn't look like any kind of train. I'm trying to draw a levitating train. Floating train, right? Levitation means floating. That's your levitating train. Okay, so so this is your starting point for the journey. I mean, this particular journey, that is. So what is it? What is that we are looking at? It has an initial velocity of 90 km per hour. It is deaccelerating. So what? It is minus half meter per second square. And it is coming to rest. So we have v is equal to 0, is it not? So these are the things that we need to make a mental note of, and better write it, draw it. So we have given, which is acceleration is half meter per second square. Then we have velocity, that is equal to 0 meter per second. And we have s, which is to be found, right? And we have u, which is 90 km per hour. Okay, so how do we go about doing this? Well, we have right, we need to convert this to kilometer per hour, sorry, meter per second, because everything is in meter and second. We need to convert this, so that's the first thing which we need to do. So we know that a kilometer is nothing but 1000 meters, and 1 hour is 60 into 60 seconds. So we have this thing, right? 1 kilometer by 1 hour is 1000 by 60 into 60 meter per second. If you guys want to do cancellation, you can do this. That is, you'll end up with 10 by 6 into 6 meter per second. All this is left to you guys if you want to do it or not. But yes, this is very important to convert. So 1 kilometer per hour is nothing but 10 by 6 into 6 meter per second. So 90 kilometer per hour would be 90 into 10 by 6 into 6. If you are confused with all of this, you can do the same substitution over here itself and get it. Dividing the work across is important. Simplifying at a place and then substituting, that makes life a lot simpler. Now 6 ones are 6 15s are. Then we have 5 3s are, no 3 5s are, and 2s are, and 2 1s are, 2 5s are. So this is 25 meter per second, right? So we have acceleration, it's negative since we are deaccelerating. Then the velocity, initial velocity is known. We have s, that is the distance traveled from point A to point B, and we have u, that is the initial velocity. Next is to look at what formula to use. S is equal to ut plus half at square. No, we need t for that. So we can go with u square is equal to v square is equal to u square plus 2as. Again, if you're confused, just write down the formulas and you'll be able to figure it out. So you can see here 1, 2, 3 things are known and S is the unknown. That's good enough. V is equal to 0, U is 25 into 25 plus 2 into minus half into S. So we have this and this getting cancelled. See, that's the power of writing things in fractions. And so this will be 0 is equal to, there's no further calculation, so this is the final calculation. This is minus S, right? Minus 1 into S is minus S. And we have S is equal to 625 meters. So that is a distance traveled by the train over here. By train is 625 meters. I think that's it, right? Yeah, that's your answer.